Hello students, let's take up the first problem on the model 6 of interest rates. So here is a question which has given the data to you. So what is the data which has been given as there is a bond price, right? So what you need to understand is the first column heading which is given the bond price are the different maturity periods, which is 100. It should be understood as this is nothing but a par value or nothing but a face value of the bond, right? Or the last column heading which is given the bond price, which has a difference in the prices, to be considered as this as a current market price of the bond, right? So it would have been directly given to you, but what actually how it has been presented in the books or how it would be asked to you, this is how you need to understand it, right? Because they will not give you the directly. So we, based on the given data, that we need to understand which is the face value of the bond and which is the current market price of the bond. Okay. The second column heading which is given us time to maturity, that is nothing but the current market price which is available for the different maturities, right? 0.25 stands for 3 months of maturity, 0.5 stands for 6 months of maturity, 1 stands for 1 year of maturity, 1.5 stands for 18 months, that is 1.5, and 2 stands for 2 years of maturity of the bond. The semi-coupon, that is the bond which is paying the semi-coupon. What is the semi-coupon? That is for 3 months there is no semi-coupon, for 6 months there is no semi-coupon, for 1 year also there is no semi-coupon. If you buy the bond for 1.5 year or for 18 months of the bond, if you buy, there is a semi-coupon of 4. It means for every 6 months you will be getting 4 rupees, right? For first 6 months 4, next 6 months 4, and next 6 months 4. 4, 4, 4, totally 12 you will be getting as in a coupon. And the bond price for the 18 months coupon is currently selling in the market for 96. Okay, the 2 years bond if you buy, there is a coupon rate and the coupon rate is 6. For first 6 months it would be giving you at 6 rupees. Fine, but the market price of such bond in the market is 101.6 is the current market price of the bond, whereas face value is the same for all the different maturities. Fine, this is about the information about the table. Now let's understand what is that it has been asking, right? There are the different sub questions, so it's a very lengthy. Usually they will ask to you for in the form of like case study, or they will split the problem into the 2 different sub questions, and it would be possibly for 10 marks or for 7 marks. Okay, let's look at each of this now. First sub question would be calculate the zero rate for the maturities of 6 months, 12 months, 18 and 24 months. What is that we need to calculate is a zero rate, right? So zero rate nothing but if the bond has been issued at deep discount, what is its rate? Fine, that is about zero rate. So the data is given for 3 months also, that is 0.25 stands for 3 months. So we don't have to calculate the zero rate for 3 months. We need to calculate the zero rate only for the 6 months, 12 months, 18 months and for 24 months. Next, the sub question would be what are the 6 months, 12 month, 18 month and 24 month par yield, right? As we understood about the par yield, nothing but the return which has been earned by the bond when it has been issued at a par value. Fine, for provided for semi-coupon payments. Then comes estimate the price of the bond. It is very simple bond valuation, where you need to calculate the price of the bond and you need to calculate about the yield nothing but YTM, yield to maturity, by considering the semi-coupon rate of 10% per annum, right? So coupon rate is given for 10% per annum, but it has been payable semi-annually. Okay. Then the fourth question would be what are the forward rates for the period of 6 months and 12 months, right? As I understood, we understood that in the discussion, when you wanted to calculate the forward rate, the base that we required is a zero rate. That we need to note the zero rate between the 2 interval of time of historical rates. That is, what is a forward rate? Between 6 months to 12 months, between 12 to 18 and between 18 to 24 months. Fine. Now let's look at each of this. First, let's calculate what is a zero rate for 6 months, right? The question is the right hand side top, right? In a small portion, the question is also given for your reference. So if you want to calculate the zero rate, what is the zero rate between the 6 months or that for 6 months, right? So for 6 months is equals to, we need to write first what is the face value of the bond. Face value of the bond minus current market price of the bond for 6 months, right? The face value of the bond is 100 minus coupon rate is, the current market price is 94.9. The difference would be 5.1. 100 minus the current market price of the bond for 6 months. You need to look at the last column heading where for 6 months what is the current market price, which is not mentioned as a current market price, it is mentioned as a bond price in the market. Okay. So face value is 100 and the current market price of the bond for the 6 month is 94.9. If you take the difference between these two, it comes out to be 5.1, right? 5.1 divided by 94 means you are buying the bond at 94.9 rupees, right? So how much is the interest that you have been earning? What is the zero rate of interest that you have been earning, right? So difference is 5.1. 5.1 divided by 94.9. It comes out to be 0.0537. If we take this 0.0537, it would be a very simple rate of interest. As you all know that in the bond market, the interest rates are subject to the continuous compounding risk-free rate of interest rates, right? To convert a simple rate of interest to the continuous compounding risk-free rate of interest, what is that we need to do here is, we need to take the natural logarithmic value, LN. That is, you can use the scientific calculator or you can use the table which I have been provided to you all in the group. Either of these you can use, right? Ln open the bracket 1 plus R. 1 plus is the standard value, R is a calculated value as you have been calculated in the previous, you got it as 0.0537. So ln of open the bracket 1 plus 0.0537, it would be 1.0537. So the value of 1.0537 ln value, if you look at from the table value, you will be getting a 0.0523. Okay. So this is the rate of interest for 6 months. Since you all know that always the interest rate would be expressed for per annum, right? It will not be expressed for 6 months. It will always say that interest rate is for per annum, it is paid semi-annually. So hence this 6 months interest rate, I need to know what is this rate for per year. So that is the reason what I will do is, this rate I will multiply with the 2, so that I will be getting this rate of interest for per annum. That is, the zero rate for the 6 months is 10.46% per annum. Okay, this is zero rate for 6 months. Now let's look at the zero rate for 1 year. The zero rate for 1 year would be, right, what is the face value of the bond? The face value of the bond is 100 minus the current market price of the bond, which is trading in the market, is for 90. 100 minus 90, it is 10. So 10 divided by 90, that is the price at which you are buying the bond, is for 90, right? 10 divided by 90, it is 0.11, right? Then convert this simple rate of interest to the continuous compounding risk-free rate of interest. I will be taking ln open the bracket 1 plus R, the formula, that is 1.011, directly I substituted here. So I will be getting 10.53 per annum, the table value. So I don't have to multiply it by 2 because the rate of interest itself is for 1 year. So I don't have to again multiply with the 2 here. Okay. So I am not multiplying it the 2 again here. It is only by directly, it is for 1 year. Right. Now the next I will be calculating the zero rate for 1.5 years. Right. What is the zero rate for 1.5 years? Right. So to calculate the zero rate for 1.5 years, if I just look at here for 1.5 years, there comes into the picture the coupon rate. Coupon rate comes into the picture. So coupon rate I need to take into the consideration when I calculate a zero rate. For 6 months and 1 year, there is no coupon, directly I used to take the difference. But I need to understand that this coupon is being paid for every 6 months. So I need to adjust this zero rate with the coupon rate. Then I need to proceed to calculate the zero rate. So what I will be doing here is, so C into, that is the coupon rate for 6 months, into e to the power of minus RT. What was the zero rate for first 6 months? That is, coupon is 4. 4 into exponential to the power of minus 0.1046. How do you got 0.1046? That is the first sub question. If you just look at 6 months zero rate, the 6 months zero rate was 0.1046 was the coupon rate for 6 months, right? Multiplied by 0.5. 0.5 is for 6 months. Fine. So 4, which is given as a semi coupon, 4 into exponential to the power of minus 0.1046 is a zero rate for 6 months, multiplied by 0.5 is the duration, that is 0.5. Rather writing 1 by 2, I am writing as 0.5 there, plus next for 1 year, right? So after again 6 months, when I cross for 1 year, again I will be getting the coupon rate, that is 4 into exponential to the power of minus 0.1053. 0.1053 is a zero rate for 1 year, multiplied by 1, right? Plus that is for 18 months. Since I am calculating the zero rate for 1.5 years, that is 1.5 years. So at 1.5 years, I will be getting my principal as well as my coupon. So the value is 104, that is 104 into e to the power of minus r into 1.5. Since I don't know what is a zero rate for 1.5 years, so I am calculating here. So that is the reason what I am taking. 104 is a principal plus interest, multiplied by exponential to the power of minus r. Minus r would be my zero rate value, which I don't know, I need to calculate. That is a reason I am taking it as minus r multiplied by 1.5 is a time, okay, that is by default we all know that is a 1.5 year bond, equal to the current market price of the bond, that is 96. So if I simplify the first two variable, 4 into exponential to the power of minus r into t, that is for 6 months plus 1 year, I will be getting the value 7.396 plus 104 into e to the power of minus r into 1.5 equal to 96, right? So if I take 7.396 on my right hand side, it will become 96 minus 7.396. So 104 into e to the power of minus r into 1.5. I am just taking the numerical and alphabetical part, and numerical part of the left hand side, that is 7.396, I am pushing to the right hand side, okay. So the difference will come as 88.604. So I will just take only exponential to the power of minus r into 1.5 and drop 104 to the right hand side. If I drop to the right hand side, it will come out of the denominator side, right? So 88.604 divided by 104, it would be the simplified value of 88.604 divided by 104 would be 0.8516. Fine. So next I need to look at some calculation on exponential to the power of minus r. How should I convert this exponential power to the right hand side? If I convert, what is that value? So if I take only r, right, what is left over is exponential to the power of minus with 1.5, right? If I convert this on the right hand side, it will become minus sign, right, minus the ln value. So exponential of minus will become ln value, minus ln value, right? So this exponential to the power of minus value will become as a minus ln, open the bracket, the simplified value what I got it is 0.8519 divided by 1.5, which was there on the product with r, that will come down for denominator 1.5, right? Next, what is that you need to do is first simplify the ln value, that is what is the ln value of 0.08519, right? If you simplify, you will be getting that as a minus value, minus 0.1608. The ln value of 0.8519 value would be as minus 0.1602. Minus into minus, it will become the value and divided by 1.5, right? So you will be getting the r value as 10.68. Okay, this is for 1.5 years. Similarly, you can calculate for 24 months. If I want to calculate 24 months, the semi-coupon rate is different again. They said it is 6 rupees. That 6 into exponential to the power of risk-free rate for, that is 0 rate for 6 months multiplied by 0.5 plus 6 the semi-coupon for 1 year multiplied by exponential to the power of 0 rate for 1 year multiplied by 1 plus 6, that is for 18 months. 6 into exponential to the power of what was the 0 rate for 18 months, just now we have calculated, multiplied by 1.5 plus 106, that is at the end of the second year, 106 into exponential to the power of minus r into 2, right, 2 is for 2 years, equal to the current market price of the bond, that is 101.6, right. If I simplify the first 3 variables, I will be getting a 16.21 plus 106 into e to the power of minus r into 2 equal to 101.6, right. 106 into exponential to the power of minus r into 2 equal to 101.6 minus 16.21, fine. So again, if I simplify and get the r value, right, so r value would be 10.8 percentage, that is 0 rate for 2 years would be 10.8 percentage. Similarly, if I want to calculate the second sub question, that is the par yield, right. What is the yield if the bond price are being issued at issued at the face value? What are the yield, right? So to calculate that, I need to take here the par yield, right? Is the for 6 months the par yield can be calculated by taking the face value of the bond, right? Face value of the bond into e to the power of minus 0 rate into time, which should be equal to current market price of the bond, right. If we take the 0 rate with the current market price, the value should be 94.9, which is equal to 94.9 currently selling in the market. So hence we can say that the 0 rate and the coupon rate are the same, hence the price is same here. The current market price and the current value of the bond is the same in the market. For 1 year, 100 into exponential to the power of minus the 1 year 0 rate multiplied by 1 equal to 90, right. So with this 0 rate, what should be the par value? The par value for this, it should be 90. Now currently selling in the market is also 90. So hence there is no difference into the par yield. Similarly, for 1.5 years, if you want to calculate the par yield, right, 4, that is for first for 1.5 years, the coupon is 4, it is given. So 4 into exponential to the power of minus 0 rate for 6 months multiplied by 0.5 plus 4 into exponential to the power of minus 0 rate for 1 year multiplied by 1 plus 104 into exponential to the power of minus 1, that is 1.5 years 0 rate multiplied by 1.5 equal to 96. It should be equal to 96. If we simplify the par yield value, the current market price should be equal to 96.06, which is almost equal to 96. Hence, again the par yield is same as the current market price. Next, for 2 years, if you calculate for 2 years, the coupon rate is 6 rupees. That is 6 into exponential to the power of minus 0 rate, which is calculated multiplied by time frame for 6 months is 0.5 plus 6 into exponential to the power of minus 0 rate for 1 year into 1 plus 6 into exponential to the power of 0 rate into 1.5 years plus 106 into exponential to the power of minus 0 rate for 2 years. This is equal to 101.6, which is almost equal to the current market price of the bond. So the par yield is again equal to the current market price of the bond. Then comes the sub question 3 into the 1. Well, sub question 3 is very simple, what we might have been done in bond valuation. Calculate the bond price of the given. Fine. If you want to calculate what the given data is, they said like coupon rate is 10% per annum paid semi-annually, right. So I take coupon of 5 for every 6 months. For every 6 months 5, for 1 year again 5, after 1.5 years 5, and 2 years 5. But the 0 rate, I will be taking what I have calculated the 0 rates. So 5 into exponential to the power of 0 rate for 6 months multiplied by 6 months duration, that is 0.5 plus 5 into exponential to the power of 0 rate for 1 year multiplied by 1 stands for 1 year time frame plus 5 into exponential to the power of 0 rate for 1.5 year multiplied by 1.5 stands for 18 months plus 105, that is end of the maturity, 1 naught, that is principal plus interest into exponential to the power of minus 0 rate for 2 years multiplied by 2 stands for 2 years of the bond, right. So comes out to be the bond price comes out to be 98.1911, that is the fair value of the bond, right. So but okay, so here we can say that the bond is overvalued in the market, fine. Then coming to the bond yield, again the simple standard formula that we use, yield to maturity is equals to coupon payment, that is C plus premium or discount divided by number of years to maturity, whole divided by current market price plus face value of the bond divided by 2. Substituting the values, coupon payment, since it is paid annually, coupon payment 10 plus 1.6 divided by 2 whole divided by 101.6 plus 100 the face value divided by 2, that is the yield to maturity comes out to be 10.7% per annum, fine. Last sub question, very important, forward rates. So what is the forward rates between the past historical zero rates, right. If you wanted to calculate the forward rates, we need to know the zero rates first, right. So the formula for forward rate is R2 T2. R2 stands for what is a zero rate, that is 2 stands for the current minus the previous. So if I say I want to calculate the forward rate between 6 months and 12 months, right. So 12 months would be the R2, time T2 would be 12 months, right. R1 would be the 6 months zero rate, R2 would be the 1 year zero rate, right. T2 is the 12 months time T is, and T1 would be the 6 months time, right. Similarly, if I want to calculate for 6 months and 12 months, R2 into T2 minus R1 T1 divided by R2 T2, R2 minus T2, right. R2 is what is the zero rate for 1 year multiplied by 1 minus what is the zero rate for 6 months multiplied by 0.5 divided by 1 minus 0.5. Simplifying, I will be getting the zero rate between 1 year and 6 months. Similarly, what is the zero rate between 12 months and 18 months? Right. So the formula would be that R3 T3 minus R2 T2 divided by T2 minus T3 minus T2. Substituting this value, right, R3 is nothing but zero rate for 1.5 years, T3 stands for time for 1.5 months, R2 stands for zero rate for 1 year, T2 stands for time for 1 year, right. So R3, what is the zero rate for 1.5 years, that is 0.1063 multiplied by 1.5 is the time duration minus zero rate for 1 year into 1 divided by 1.5 minus 1. I will be getting the forward rate between 12 and 18 months. Similarly, if I take for 18 and 24 months, it would be R4 T4 minus R3 T3, right. R4 stands for what is the zero rate for 2 years, T4 stands for what is the time to maturity for 2 years, right. R3 stands for zero rate for 0 rates for 18 months, that is 1.5 years, what is the zero rate, and T3 stands for what is the time to maturity for 18 months or 1.5 years, fine. Substituting, I will be getting as 11.5%. This is nothing but zero rates for 6 months to 12, 12 to 18, 18 to 24, right. So here we will be stopping about the solution for the question 1. We will take up the next question in the next discussion.